Hey, what's up everybody? My name is Coach Anderson, and today we're diving into an exciting new topic. We're going to talk about Unit 5 of the solar system, and more specifically, we're going to take a look at Earth's movement and the changing seasons. Now, have you ever wondered why we have winter snow, summer sunshine, and everything in between? Well, it's actually all thanks to Earth's tilt and its movement around the sun. In this video, we'll model Earth's tilt and revolution, showing you step by step how these motions create the seasons. By the end, you'll be able to explain why it's summer in one part of the world and winter in another. Now, let's explore the science behind the seasons together, but first begin by taking a look at our phenomenon. Have you ever heard of the midnight sun? Well, it's a phenomenon where the sun doesn't set for days or even weeks at a time. But why does this happen? Especially in places like the Arctic Circle. It all comes down to Earth's tilt. Now, Earth's axis is tilted at an angle of about 23.5 degrees. As our planet orbits the sun, this tilt causes some parts of the Earth to lean closer to the sun, while others tilt away. During summer in the northern hemisphere, the North Pole is tilted towards the sun. This means that areas within the Arctic Circle receive continuous sunlight for several weeks, even during the night. The sun appears to skim the horizon but never fully sets. This is what creates the midnight sun phenomenon. Look here. Now, and in winter, the opposite happens. The North Pole tilts away from the sun, and regions in the Arctic Circle experience weeks of total darkness, known as the polar night. So, the sun's behavior in the Arctic isn't magic. It's all about the tilt and Earth's position in its orbit. Pretty amazing, right? Now, here's something to think about. How do you think life has adapted in these areas with such extreme light and dark cycles? Think about it, and we'll talk more in class this week. All right, so we're going to talk about Earth's movement and the seasons today, and our two main objectives are to understand how Earth's tilt affects the amount of sunlight that it receives, as well as what causes the cycles of the seasons. All right, so how does Earth's tilt affect the amount of sunlight it receives? Well, Earth is tilted on a 23.5 degree axis, all right? If we pretend this basketball is the Earth, there's a line that crosses it diagonally from north to south pole. Now, on this axis, Earth spins or rotates, right? And it does that every 24 hours, which gives us day and night. So, again, rotation is when Earth spins on its axis, and it gives us day and night. Now, Earth's movement around the sun is known as a revolution, okay? The word revolve or revolution means to go around. Now, Earth travels around the sun about once every 365 days, or once a year, okay? Revolution is when the Earth goes around the sun. All right, one thing you should know about the Earth is that it's divided into hemispheres, which means half of the Earth, okay? We have the northern hemisphere and the southern hemisphere, okay? Now, because the Earth is tilted, if it's tilted away from the sun, it's going to receive less direct sun rays, and if it's tilted towards the sun, it's going to receive more direct sun rays. Now, what I want you to do is pause this video and see if you can identify where points A, B, and C go for this question. All right, go ahead and check your answers and see if you got it right. All right, let's keep the ball rolling and talk about a few more key vocabulary words. Now, what causes the cycle of the seasons? Well, a season is a period of the year with certain weather patterns and day lengths. Seasons happen all because Earth's axis is tilted. Now, during the year, the amount of solar energy and daylight hours vary from place to place. A solstice is the day when the sun is at its greatest distance north or south of the equator. On the other hand, halfway between the solstices, an equinox occurs. All right, let's briefly recap everything that we just talked about, okay? And there's a great picture up here for you to see all these things, but let's pretend that this basketball represents the Earth. We know that the Earth is tilted on a 23.5 degree axis, which means part of the Earth is in sunlight and the other part is in darkness. Now, the Earth rotates around its axis, okay? So it spins or rotates. Again, Earth spins or rotates on its axis one time every 24 hours, which gives us day and night. Now, Earth also revolves or goes around the sun every 365 days or 1 year. Okay? Now, because of Earth's tilted axis, each hemisphere is tilted toward the sun for part of the year and away from the sun for another part of the year. The amount of sunlight at different places on Earth varies throughout the year, which causes the change in seasons. Go ahead and take a look at these pictures. And I want you to think about how the sun's path across the sky changes throughout the year. You see, a solstice is a day of the year when the noon sun reaches its highest or lowest point in the sky. At the summer solstice, the sun appears highest in the sky. At the winter solstice, the sun appears lowest in the sky. Solstices occur twice a year in June and December. The June solstice is the summer solstice for the northern hemisphere, but the winter solstice for the southern hemisphere. On an equinox, day and night are the exact same length because neither hemisphere is tilted towards the sun. An equinox occurs halfway between the solstices. All right, Happy New Year, everybody. Thank you for joining in today. I hope you learned something new. I look forward to seeing you back in class, and until then, have a great day.